All right, so yesterday we learned about the factored form of the quadratic, and we learned some new terms such as the zeros, which would be your x-intercepts, your axis of symmetry, which is that vertical line that makes sort of a mirror image on both sides. Vertex we know. A y-intercept we're going to look at as well. And what we're going to do is right now is going to practice for a couple of examples in intercept form. We're going to find those x-intercepts, the axis of symmetry, the vertex. I'm also going to show you how to find the y-intercepts, and then we're going to sketch the graph based on this information. Alright, so let's start with the first one. So the first one, it looks like here we have x plus 1. So one of the zeros would be when x equals minus 1. Okay, this one I'm not going to do very often, but in this case it wouldn't be plus 5. If we go back and look at the equation and say, okay, if we want that bracket to equal 0, what does x actually need to be? So rearranging, we get 4x equals, on the other side, if we bring this term over, right, basically adding it to both sides, we get positive 5. And then to isolate x, since it's being multiplied by 4, we'll do the opposite operation and divide by 4. Okay. We get x equal to 5 over 4, right, which is the same as 1.25. So those are our two x-intercepts. We have one at a value of 1.25 and one at a value of negative 1. Okay, so let me just do a rough sketch here. Let's say this would be negative 1. So I'll call that point negative 1 and 0. That's our first x-intercept, and the next one is over here at 1.25 and 0. Okay, I'm sort of running out of space to do this question, but that's okay. All right, so we found the zeros. Next, axis of symmetry. So to find that, remember it's a vertical line that is right in the middle of those 2 points. So you can see this is negative 1. This isn't positive 1. It's a little bit more. So our vertical line is going to be a little bit to the right of that y-axis. So to figure out exactly where we're going to take the average, so the axis of symmetry, we'll have our x value equal to minus 1 plus 1.25, and then divide by 2. So when we do that, we get something very small, so 0.125. So that is where our axis of symmetry is going to be. But as a fraction form, that would be 1 over 8 if you wanted to keep it as a fraction. So our point is x equals 1 over 8, or 0.125. Okay, so that's our axis of symmetry. Now our axis of symmetry is where the vertex is actually located. So the vertex is going to be somewhere on that axis of symmetry. Now we also need to know, if we're going to sketch it later, whether or not it opens up or if it opens down. But in this case right here, it doesn't look like we have an a value, but our a value is actually equal to 1. And since it's positive, it's actually going to open up. Right? So I'm just going to write opens up. Even though the question doesn't ask you to figure out whether or not it opens up or not, because it asks you to sketch, you're going to need to know whether or not it opens up. And we're also going to need to know where on that axis of symmetry is the vertex. So what we're going to do is we're going to take 1 over 8 and substitute that back into this function. So we're essentially finding P at 1, 8. Okay, so when x is equal to 1, 8, we have 4 times 1 over 8. Again, if you prefer leaving that as a decimal, that's fine. Minus 5. All times by, here we have x plus 1, or 1 over 8 plus 1. Okay. All right, so when you do this, you will get, well, 4 over 8 is a half. Minus 5 multiplied by 1 over 8 plus 1. Okay, so if you want, you can put that on your calculator. You should get, if you leave it as a decimal, you'll get minus 5.1. So it's going to be somewhere down here. It actually, based on what my scale is, it's going to be a lot lower than that. But this is just a sketch. This is the point 0.125 and minus 5.1. So that's where our vertex is. Now it also tries to ask us to find one more thing. We could sketch this right now. We know our vertex points, we know our X-intercepts, so I could sort of sketch like this. I know it opens up, and I can do the same thing on the other side. But it does ask us to find a Y-intercept. So basically it wants to know this point. Okay, so we need to add that to our graph. Now that point happens when our x value is 0. So I know it's going to be 0 and something. So to figure out what that something is, what I need to do is find, okay, what is the function p at 0 equal to? So I'm substituting 0 for x. So 4 times x is going to be 0. So in the first bracket, I'm just left with negative 5. Here we have x plus 1. Well, x is 0. So it's going to have 1. Negative 5 times 1 is negative 5. So it's slightly above there, minus 5. Okay? So let me just pause there, see how everybody's doing. All right, so we have 3 other questions, B, C, and D. Okay, all math questions have A, B, C, D, E, okay? But they all look a little bit more challenging. Right? They all look like they're not in intercept form or in factored form, and it's true, they are not. So what we have to do is first factor them. So if we look at B, okay, first thing you should always do is there a common factor. Find that greatest common factor. In this case, all those coefficients are divisible by 3. And I also want to get rid of that negative in front of my x squared term here. This up a bit. Okay, so all of these are divisible by 3, and I want to get rid of that negative. So what I'm going to do is I'm going to pull out a negative 3. So now I'm left with x squared plus 2x minus 15. So now I need to factor. This is now a simple trinomial. I need to factor it. So I need to find 2 numbers that multiply to give negative 15 and add to give positive 2. So those 2 numbers are 5 and negative 3. So now I have it in factored form. Okay, I'm going to help you factor the other ones, and then I'm going to let you try these questions on your own. Okay, again for B, this isn't even a trinomial, it's a binomial. But there is a common factor here. Again, I don't want that x squared term to have a negative, so I'm going to pull out a negative 3 again. But x is also a common factor, so negative 3x. And that leaves me with, I'm going to write this term first, so x, and then minus 2. Now this looks a little bit different. This still doesn't really look like it's in our typical factored form. But it actually is, because if you're looking for your zeros, right? Or your X-intercepts. Well, you can look at this and say, here's one term, here's another. This multiplies into that. If either one of those is 0, multiplied by the other number, well, 0 multiplied by any number is still 0. So what would this need to be 0? Well, if x equals 0, well, then negative 3 times 0 is just 0. And then 0 times by this bracket would be 0 as well. So x equals 0 is one possible x-intercept. Okay? And then the other one would be right in here, where x would be equal to 2. Okay, so that's my hints for that question. You can continue on with that one. Let's go up and look at this one. This one, it almost looks like it could be a difference of squares, but the problem is 50 doesn't work. But you might realize these are both even numbers, so I can pull out a 2 as our common factor. When I do that, I get 4x squared minus 25. Oh, this is great. 50 didn't work before, but 25 does, because 25 is 5 squared. The 8 actually didn't even work before, but now it does, because it's 4, and 2x all squared is 4x squared. So now I can write this as 2 times 2x minus 5 and 2x plus 5. Okay, so now I have it in factored form. I can go ahead and find my zeros, my axis of symmetry, vertex, y-intercept, and sketch it. So I'm going to pause there. Alright, so before I move on, I wanted to show you what this looks like. So here you have factored form. You might not be able to see, but there's an a there. And then you have your x minus r and x minus s. This controls the a value. And just like before when we dealt with vertex mode, right, all it does is stretch and compress. And then if it's positive, it opens up. And if it's negative, it opens down. So that's what a does, just like before. Just leave a at 1 for now. Now this is r and this is s. Currently, r is set to 0, because you can see right there. R is our x-intercept, or one of our zeros, and s is set to 6. You can see that right there. Now if I change one of them, it looks kind of freaky. But all that's happening is, notice that this x-intercept, the line stays the same. The line always goes through there. All that happens is this x-intercept changes as it goes around, and you can see that happening. And the same thing would happen if I were to change the other x-intercept. This one will stay the same while this one moves. And here I have a line. This is a vertical line. This will be our axis of symmetry. And you can see always it would need to be placed directly in between your two x-intercepts in order to get a nice mirror image on one side and the other, which is our line of symmetry. Okay, so this is not a nice mirror image. That's not a nice mirror image. Right there. All right. Now, one more thing I want to point out is as I change these, you'll notice there's always an x-intercept. If I put them equal to each other, I can get it so that there's only one x-intercept, in this case right at 0. But I cannot get a situation where there's no x-intercept. For example, a quadratic that would look like this, or one down here that looks like this. We've seen those before when we analyzed vertex form. But when you factor something, you're looking for the zeros. So if there are no zeros, you're not going to be able to factor it. And so factored form can only be used when you have at least one zero. Okay? You might not be able to use factored form. And so if you have a quadratic in standard form, you're trying to factor it and you realize you can't. There's probably a reason for that. And so we'll look at, in chapter 4, taking standard form and changing it to look like vertex form. It's called completing the square. So we'll do that later. I just wanted to point out the differences here and what it would look like. Okay, so on the back, we're doing the same type of thing as on the front of the page, but on the back, we're doing it in a different order. So before, it gave us the equation and asked us to find the zeros, the axis of symmetry, the vertex, and so on. But now we don't have an equation. We don't have one in factored form, we don't have one in standard form. But we need to find them. Now what they do give us are the zeros and that maximum or minimum point. We don't know if it's a maximum or minimum. So let's figure out how we're going to do this. Let's start with the zeros. Here's our equation. Y equals A times X minus R and X minus S. Now, this is telling us what the zeros need to be. So how do I actually write this into the equation? I still don't know what A is, but that's going to be R or S. I mean, it doesn't really matter which order you put it in. So we're going to have X minus 1. So in this case, if you look at this, you can see, X would have to be 1 in this case. So that's one of our options. And the other one would be S is a value of 7. So X minus 7. So I've almost got the equation there, just from the zeros. I just don't know what A is. Well, if I know what the zeros are, I can figure out what the axis of symmetry is. All we're going to do is find the average. Okay, so the average would be 1 plus 7, all divided by 2, right, which is 8. 1 plus 7 is 8, divided by 2 is 4. So the axis of symmetry is at x equals 4. And I know that's where the vertex is going to be. Therefore, this is telling me what that y-coordinate is for the vertex, because that's our maximum or minimum point. So I know the vertex is at 4 and minus 18. So how is that going to help me figure out what the actual equations are? And here's how it's actually going to help. We need to still find out what A is. In order to figure out what A is, we need a point on our parabola. Any point. Doesn't matter what point it is, but we need some value for x with a corresponding value for y that I can sub in this equation for x and y, and therefore solve for A. That vertex is our point. It doesn't have to be the vertex, but the vertex certainly is an easy point to grab. So here's our x value, and here's our y value. So y I'm going to write as minus 18 equals, I don't know A, that's what I'm trying to find, and our x values are 4. So 4 minus 1, and over here, 4 minus 7. So now we have an equation that we need to solve for A. So let's take that step by step. Nothing I'm really going to do with the minus 18 yet. Same with A. But let me simplify each bracket. So 4 minus 1 is 3. And 4 minus 7 is minus 3. Okay, I'm still going to leave that minus 18 there. What I can do here is multiply these two brackets. So 3 times minus 3 is minus 9. So now I have a number being multiplied by A. If I want to isolate for A, do that opposite operation and divide both sides by that number. On the right side, our number is gone, and we're just left with A. And on our other side, we see what A equals. Minus 18 divided by minus 9. The two negative cancels, and 18 divided by 9 is 2. Therefore, I know this equation now because I know what the values for A R, and S's. We're going to leave y and x. I'm not going to keep y and x as 4 and negative 18 because that's only one example on the entire parabola. That's just the vertex. Right? Whereas a line or a parabola or any continuous graph has an infinite number of points on it. So we want to know all the points. So we're going to leave y and x there. That's what they actually describe. I'm going to have a as 2. And then r is 1, just like before. And s as minus 7. So there is our equation in factored form, which I can write up here. Y equals 2, x minus 1, x minus 7. And once you have factored form, getting standard form isn't too bad. We're just going to expand and simplify. So I'll leave the 2 here, and I'm going to FOIL the rest, like this. So you get x squared minus x minus 7x, and minus 1 times minus 7 is plus 7, double negative. Here I can collect like terms. So I'm still just leaving that 2 out there until I'm ready for it. So you have x squared minus 1 and minus 7 give me minus 8 plus 7. Now is when I can take that 2 and distribute it throughout that trinomial. So we get 2x squared. 2 times minus 8 gives us minus 16x plus 14. So there is our equation in standard form. Let me just pause there.